Hi there, my name is Austin Kinross, and I'm a developer on the DirectX team at Microsoft. Today, I'm going to talk to you all about PIX on Windows. I'm firstly going to give you all a high-level overview about PIX, before I dive into what's new and exciting in both timing captures and GPU captures. So PIX on Windows, it's Microsoft's debugging and profiling tool for DirectX applications on Windows 10. PIX supports all DirectX 12 capable GPUs from AMD, Intel, and NVIDIA. And in the past year, we've added support for Qualcomm-based GPUs on ARM64 devices, such as a Surface Pro X or a HoloLens 2. PIX on Windows is closely related to Xbox PIX, although it's not quite the same product. It shares the same UI though, which provides a nice consistent experience for developers who are working on both platforms. Of course, Xbox PIX has some features that are not available in PIX on Windows today, but we've been working hard over the past couple of years to close the gap between the two, and I'm excited to show more about that later. Finally, in case you don't already know, PIX on Windows is a standalone tool that's available for download from our blog. It doesn't depend on any Visual Studio installations or Xbox SDKs or anything like that. We release a new version every 2 or 3 months or so I recommend checking out the PIX blog and making sure that you're using the latest version. Now, PIX works by letting you take a capture of your game or application, and then opening that capture for analysis in PIX later on. PIX supports several types of capture that each serve a different purpose. Firstly, there are timing captures. These are our lightweight capture type that collect CPU and GPU timing information, amongst other things, while your game or application is running. That timing capture information is then serialized into a capture file, and when you open it later on for PIX and analysis, you can see the GPU and CPU timing information back from when your game was originally running. GPU captures, meanwhile, they're our heavyweight capture type. They inject themselves into your game, and they intercept all of your game's GPU work. When you trigger a capture, typically of a frame or so, we serialize that GPU work from that frame into a capture file. And when you open the capture file for analysis in PIX later on, PIX will repeatedly replay that GPU work over and over again, while you can analyze it using different tools available in PIX. I'll show you more about that later. PIX supports several other capture types too, such as memory allocations and file I/O captures. Those are useful to developers who are working in those feature areas, but they typically aren't so useful for DirectX developers, so I'm not going to talk more about those today. Instead, I'm going to focus on GPU captures and timing captures. Now that we know roughly how they work, let's talk about the kinds of problems that they can help you solve in your game or application, and how they can make it run even better on Windows 10. Well, GPU captures, they're focused on the what, like what exactly was your game or application doing during that captured region. They are great at helping you, say, debug rendering issues in your game or application, such as corruption and lighting issues and things like that. But GPU captures, they also offer a variety of performance optimization features to help you, say, understand why your frame is taking longer than you expected. These same features, they can also be used to understand why specific GPU operations are slower than you expected as well. I'll show you more about that later. Timing captures, meanwhile, they're more focused on the when than the what. Like, when exactly did events occur in your game? When did they occur relative to each other? And how long did they take? And things like that. Timing captures, they're great for helping you, say, track down a frame rate hitch in your game every so often, or help you understand why your GPU is stalled, waiting for your CPU work to complete. They're also the best way to see timing data for your GPU async compute work. So actually, while I'm talking about timing captures, let's dive deeper into them and see what's new and exciting about them. So the big news was that in 2019, we introduced a major new refresh to timing captures, which I'm very excited about. The key change, compared to previous timing captures, is that you can now capture for minutes or hours, or even longer if you wanted to. Whereas previously in PIX, you were only able to capture for, say, 2 seconds of data. This is a major step forward. It lets you take a timing capture of, say, a whole gaming session, and then afterwards go back and analyse why frame rate hitches or other problems occurred during your gaming session. These timing captures, they're available today in both PIX on Windows and Xbox PIX with the same consistent UI experience across both platforms. As an example, you can see here that this is a timing capture of a real game that's running on Windows 10, and you can see that it's an 11-minute timing capture of the game. But of course, we could go longer if we wanted to. But even 10 minutes, 11 minutes of timing data or more, it's overwhelming to see it at once right on the screen. How do you analyze so much data? Luckily, PIX has several tools available to help you do this and help you distill the information down into more bite-sized chunks. Firstly, you can zoom into any region of your capture. So as an example in this screenshot, you can see that it's a 10 millisecond region of that previous capture that I just showed to you. Here, you can see the CPU and GPU timing information within this 10 millisecond region. And if you take a look at the green highlighted range there, you can see async compute work that's occurring on a compute queue. And you can see how it overlaps with GPU work that's being performed on a different direct queue at the same time. And if you look even more closely just in the monitor lane there next to this green arrow, you'll see a vsync. And this means that you can see where the vsyncs occurred relative to your GPU work, and if you missed a vsync and things like that. So while you can deep dive into a region of your capture, you can also use the metrics view to get a better overview of trends or patterns that occur during the course of your capture. So for example, you can take a PIX marker region that occurs every so often, say every frame or something like that, and plot a graph showing how its duration varies over the course of your capture. So this screenshot here, it shows a certain PIX marker region that occurs every frame or so, and it shows that its duration spikes wildly every 100 frames or so. Now this is an artificial example, but it shows you the kind of analysis that you can do to understand, say, why a frame rate hitch occurs in your game and which part of your game was responsible for the frame rate hitch. Before I move on, I wanted to call out something new in the next version of Windows 10 that makes timing captures even better. We've worked hard to reduce the performance overhead while you're taking a timing capture, and particularly the overhead inside execute command lists calls. Some eagle-eyed PIX users out there, you've actually spotted this and contacted us about it. So I'm very happy to share that the overhead has been substantially reduced now. These overhead improvements, they're available in the next version of Windows with participating drivers, and both of which are available today to Windows Insider users. So now, let's move on to GPU captures. So firstly, as has been previously shown on Mixer, GPU captures now support all of the latest DirectX 12 Ultimate features. To recap the previous presentations, features like mesh shaders and sampler feedback and variable rate shading, they're all fully supported in GPU captures, and they probably work as you would expect. You can capture and replay the API calls. You can see the parameters you passed to them. You can see the resources they used, such as the shading rate image or the sampler feedback map. Or you can even debug your mesh and amplification shaders using PIX's shader debugging tool. DirectX ray tracing, well, that one's a bit different since it's a whole new rendering paradigm. But you can still capture and replay all of your API calls and see all of the resources used in your shaders. And we also have a number of new features to help you debug and optimize your DirectX ray tracing work. I'm not going to dig too much into those today, but I recommend checking out Jianyei's talk from Mixer already, or going to the PIX blog for more information. And of course, it goes without saying that these features, they work on both Xbox PIX and Windows PIX with a consistent UI experience. They will be available later this month, so March 2020, in PIX on Windows and available for download from our blog. Now, earlier I said that GPU captures, they're great at helping you optimize that frame or so that you've captured, or even optimizing individual GPU operations within that frame. Let's take a look at how PIX can help you do that. Firstly, there are the eventless counters. These are per event counter values that PIX shows next to each event in its GPU capture event list. These counters include a wide range of low-level hardware counters from each GPU manufacturer. But they also include other counters such as raw timing information or even D3D specific counters such as number of pixel shader invocations. The eventless counters are a great way to understand properties of individual events, but they also allow you to see properties of regions of GPU work that you've annotated using your PIX markers. So for example, in this screenshot here, you can see that individual GPU operations, such as clear render target view, well, they have counter values, but so do the regions of work, such as main render and scene render. And finally, I just wanted to point out that button in the top right-hand corner there. That's the one you would use to see which eventless counters are supported on your current GPU. Now, I said timing information is available in the event list UI, but we also draw it in this view, which we call the timeline. Here, the horizontal axis represents time, and each blue bar that you see in the middle of the screen corresponds to one GPU event. The start of the blue bar represents when that GPU event began executing on the GPU, and the end is when it finished. Well, you can see that there are a lot of overlapping blue bars here, and that demonstrates the inherent parallelism in modern GPUs, since it shows that there are multiple GPU operations in flight at any given point in time. The multicolored graph below this, well, that's the occupancy graph, and that helps you understand the parallelism in much greater detail. It helps you understand, for example, how much of your GPU is being spent on any given event at any given point in time. And it helps you identify which GPU events are perhaps limiting your game's potential to make full use of the GPU, due to factors such as register pressure and things like that. My colleague Sean Hargreaves gave a great talk at GDC in 2018 where he dug into the occupancy graph in much greater detail. So I recommend checking out that talk, which is available on MSDN's Channel 9 blog, or checking out the PIX blog for more documentation about the occupancy graph. So in the past year, we've gone even further by adding support for high-frequency counters to PIX. These are low-level GPU hardware counters that are similar to the eventless counters, but instead they're sampled at a very high rate, typically hundreds of thousands of times per second. The counter values are then plotted in a graph, which you can see at the bottom of the screenshot here. The high-frequency counter graphs, well, they're great at helping you understand what is going on within individual GPU events, and especially long-lived ones such as dispatch arrays. But they're also great at giving you a nice visual overview of the counter's value over time and help you easily spot trends or spikes and things like that. The high-frequency counters are specific to each GPU manufacturer that supports them. You can click on this button next to the arrow up there to see which counters are supported on your current GPU. As an example, this screenshot shows a counter from AMD, which you can see has a really nice description to help you interpret the counter's values and use it to improve your GPU performance. Hopefully the contents of this screenshot look very familiar to Xbox PIX users. I think it shows just how far PIX on Windows has come to closing the gap with Xbox PIX. And indeed, all of the deep hardware profiling features that I've just talked about, so timing analysis, the event list counters, the occupancy graph, and high-frequency counters, they're all available today on Xbox and almost all DirectX 12 capable hardware from AMD, Intel, and Nvidia that's been released since 2016. This is deeper multi-platform insight into your GPU work than any other tool. And best of all, these features use the same consistent UI on all of these platforms, on Windows, GPU, and Xbox. Now moving on, there's another performance optimization tool in PIX on Windows that we call the warnings view. Instead of giving you insight into what the GPU is doing, the warnings view detects inefficient API usage patterns in your D3D12 work and suggests a better way to do things instead. These warnings came out of the extensive work that the DirectX team did to profile and optimize DirectX 12 titles. And over time, we've added new warnings based on the extensive work that our IHV partners have done to profile and optimize DirectX 12 titles on their hardware. And indeed, each of these PIX warnings corresponds to something that a real game has done in the past and that needed to be addressed to improve performance. As an example, here are the warnings from a real game that's in development at Microsoft today. As you can see, there's some low-hanging fruit here that the developers could address to quickly gain some performance in their game. A different internal Microsoft project saw an 11% GPU perf win by addressing most of the PIX warnings that their game generated, so I recommend checking these warnings out. So some of the warnings are generated when you first open your capture in the PIX UI, and some of them are generated when you start analysis on the capture. But the vast majority of them are generated when you click on this button, the Run Warnings Analysis button. My personal favourite warnings are this one, called Descriptor Table Recommendations, and a similar one above it called Descriptor Duplication Detected. As you can see, there's a lot of text here to help you understand the warning in great detail. But in short, the warning flags common but generally poor descriptor usage patterns that limit certain types of descriptor caching on some hardware. Addressing this warning isn't easy, but I'm aware of two major game engines that you've probably heard of that both got between a 3 to 8% GPU perf win in a majority of scenes on a large amount of hardware out there today. Now, before we wrap up, there's two other things that I'd like to show you in GPU captures. Firstly, there's PIX's support for taking GPU captures of DirectX 11 workloads. PIX supports this via the D3D 11 on 12 translation layer, which is an implementation of a D3D 11 driver in terms of the D3D 12 API. In fact, for those of you who don't know, Microsoft released the source for D3D 11 on 12 on GitHub earlier this year, so you're welcome to check it out and contribute back to it even. But meanwhile, in PIX, we have an option to force D3D 11 on 12. You can see this in the drop-down menu here. This will force any D3D 11 workloads in your application to use D3D 11 on 12. This ultimately means that your application's D3D 11 workload is executed via the 12 runtime, which makes it possible for PIX to capture it. After taking a capture and opening it in PIX, you will see the D3D 12 API calls that were made by 11 on 12. And these map back fairly closely and surprisingly closely to your D3D 11 code. You'll also see any GPU annotations that you may have made in your D3D 11 code, which will help you map PIX insights back to your D3D 11 work. We think that this feature is a great way for you to use PIX's deep hardware profiling features with your D3D 11 applications. And finally, I wanted to highlight a new feature that we recently added to PIX based on customer feedback that we call Launch Suspended. Launching an app suspended gives you an opportunity to start a PIX capture, either a GPU capture or a timing capture, before you resume your application. So in other words, it lets you take a capture right from the beginning of your application's execution. This is great for, say, taking a GPU capture of the first frame of your game or the loading screen. But it's also great for taking a capture of short-lived applications. So for example, you might have a WinML application that spins up for a few milliseconds before terminating. Now, briefly, I wanted to share with you that we've very much heard your feedback about PIX, and as a direct result of it, we're particularly focused on two things in the medium term: performance and usability improvements. We don't have specifics that we can share just yet about this, but the initial results are exciting, and I'm looking forward to sharing more about this with you in the coming months. Now, if you have any other feedback about PIX that you would like to share, or if you experience any issues with PIX, then please feel free to reach out to us. These are the two best ways to reach us. Firstly, there's the Send Feedback button in the PIX UI. It's this speech bubble icon in the top right-hand corner. When you click on that, it will open up a new email that you can fill in with any details or information that you want to share with us. The second way is the DirectX Discord server, which we're very active on, and there's even a dedicated PIX channel on there for you to reach out to us. Now, I'm aware that in some products, feedback emails, they often go unanswered or ignored, but PIX is different to that, and I wanted to show you how. PIX team, we reply to 80% of customer emails that are sent via the Send Feedback button in the PIX UI within 4 business hours of receiving them. And this year, we've replied to 100% of emails within 2 business days. And these replies that we send, they're not automated responses either. They're meaningful replies from people on the development team that help unblock customers or ask for more details to help us reproduce issues that we report. So please feel free to get in touch with us at any issues or questions that you have. And with that, please also check out the PIX blog for more information or to download PIX on Windows. Thank you.